Example number 5. The last major thing that we need to learn with our sum and difference identities is pi over 12 questions. I think there was a streak of 10 years in a row where every exam, twice a year, had a pi over 12 question on it. In the last, it's just like, well, if you think about your unit circle, why pi over 12 question? If you think about your unit circle, and I'll drop one on the floor here, and you look at the spacing, do you notice that there's 15 degrees, or pi over 12 radians, in between 30 and 45, 45 and 60? That's 15 degree space. But there's a 30 degree space between 0 and 30, and a 30 degree space between 60 and 90. It's like it would be so much more even if those were filled in.
Oh, that's what it does.
That's what it does. We are able to find out sine, cos, and tan of 15 degrees without our calculator, of 75 degrees without our calculator. And that's what makes a pi over 12 question.
Pi over 12 is 12, 15 degrees?
Yeah. Pi over 12 is 15 degrees.
Right, it's not quite, but...
So if you wanted to find the exact value of cos of pi over 12, or sine of 75 degrees, or any other one, what we're going to do, that sigh of relief when you get to write lots of notes. You're going to use your pi over 3, pi over 4, and pi over 6 families that you already know, and add or subtract them to get the pi over 12 angle you want to find. And then you can use your alpha beta formulas to make it work. Well, you're not going to use the 90, you're not going to use the axes family. Because they don't actually. So how would you get to 15 degrees from 90? You'd have to subtract 75, and you don't know 75. You knew 30 and 45, but that's not axes family. So 45 minus 30 would give you 50 degrees. 45 plus 30 would give you 75 degrees. But if you want 75 degrees and you want to use 90, you have to subtract 15, and that's not on your pi plate. So you have to use values on your pi plate, add or subtract them to get the angle you want. Oh, here we go. This is probably a good idea. Get that code again. Where did I find that code? I'll put it in the video. There we go. There we are. No, I missed it. There's the code. Funutik 7. Perfect. Now it's on the video as well. And we're back. So the first one we want to find in A is cos of pi over 12. Can you see, using pi over 3, pi over 4, and pi over 6, is there a way you could add or subtract to get 1 pi over 12? And I wrote them all as pi over 12s in brackets to make it easier. Could you use 4 pi over 12, 3 pi over 12, and 2 pi over 12 to add or subtract to get 1 pi over 12? 4 pi over 12 minus 3 pi over 12. Or 3 pi over 12 minus 2 pi over 12. Either would work, so you have a choice. So I chose 4 pi over 12 minus 3 pi over 12, which, when it's simplified, is pi over 3 minus pi over 4. Oh, the slow writers. Then, once you've got cos of pi over 3 minus pi over 4, you go to your alpha and beta formula. Pi over 3 is your alpha, pi over 4 is your beta. Plug everything in, and everything's on your unit circle. Guaranteed to work every time. So now you're going to plug in those values. What's cos of pi over 3? Well, it's 1/2. Cos of pi over 4, root 2 over 2. And you have to write your answer as a single fraction. So you have to multiply your fractions. You'll have a common denominator of 4. So you can put it together to be root 2 plus root 6 all over 4. Something neat happens with the pi over 12 families, whether it's the 5 pi over 12 family or the pi over 12 family, you will always get a root 2, a root 6, and a 4. But sometimes the root 2 will be negative. Sometimes the root 6 will be negative. Sometimes they'll both be negative. Sometimes, like this one, they're both positive. So our second example was 75 degrees. So you have to think, well, what are two things that add or subtract to 75 degrees that are on my pie plate? 45 degrees and 30 degrees. So that's your alpha and your beta. Too fast? All good. And plug that in, figure out each thing separately, and you get another root 6 plus root 2 all over 4. Yes, for sine and cos. If you go to tan, you'll have root 3's in there. Okay, now before we get to our next question, you all get a scrap piece of paper. I think there's 2 there. You can give one to Andre. And on this scrap piece of paper, you're going to write 17 pi over 12. Because our next question is going to ask us to find the exact value of cos of 17 pi over 12. But on your scrap piece of paper, I just want you to write 17 pi over 12 equals, and you need to put 2 things from your pie plate anywhere on your pie plate, anything coterminal with anything on your pie plate, that add or subtract to get 17 pi over 12. It can only be because you need an alpha plus beta or an alpha minus beta, okay? And there's a little bit of a rush because you're not allowed to find the same one as someone else. So as soon as you find one, you want to tell me, because if yours is right, I put it up on the board and then you're done. But if you haven't found one, then you're like, oh, I just about found that one. Now you have to find a different one. So 2 things that add or subtract to get 17 pi over 12. Don't worry, there's an infinite amount of answers that work. There's also an infinite amount of answers that don't work, but you have to find 2 that work.
The amount of answers that don't work is infinitely bigger.
That's right.
So it's like,
You can't just guess and hope.
yeah.
Yes, we got one. That one's off. You're not allowed to use that one. If you think this makes 8 pi over 12, and this makes 9 pi over 12, 8 pi over 12 plus 9 pi over 12 is 17 pi over 12. Okay, we got 5. Here, I'll add another one. How about 9 pi over 4 minus 5 pi over 6?
5 pi over 6 plus 3 pi over
5 pi over 6 plus 3 pi over 4? No. That'll make 19 pi over 12.
4. Well, that's 10 pi over 12 plus
9
9
pi
pi over 12.
makes 19. Okay. So let's look for some things that each of these have in common. Well, obviously, they all add to 17 pi over 12 or subtract to 17 pi over 12. That's why they're listed. But the question is, what do the individual ones have in common?
They all have 4 as a denominator.
They always use a pi over 4. You can never find a pi over 12 question without a pi over 4. Why? Well, I kind of gave a hint earlier. If you look at your pi over 4, it makes 3 pi over 12. That's an odd number, pi over 12, whereas the other ones are all even pi over 12s. And if you have to add or subtract 2 things to get an odd number, like 17, one has to be odd, one has to be even. So you have to use pi over 4 every single time. But that's going to be super helpful because if you want to find 17 pi over 12, pick a pi over 4. 3 pi over 4? 3 pi over 4 is 9 pi over 12. What do we need to get to 17? Add or subtract? Add. How many do you need to add to get to 17? 8. That is the original one. And then that works, right? Now reduce them, and every time you reduce, you will get things on your pi plate. Works every single time.
Is
So
that what you meant by there's infinity?
yeah, pick any. You could pick, pick negative. Which negative pi over 4 have we? We've only used. Oh, we had negative pi over 4. Let's do negative 3 pi over 4. So that would be something. Subtract 9 pi over 12. What would have to go here to get 17? 26 pi over 12. What does 26 pi over 12 reduce to? 13 pi over 6. That's coterminal with pi over 6. It's on your unit circle. So you can choose any pi over 4 to start with. Most people like the adding ones, okay? But it doesn't have to be. It can be subtracting as well. So in the one that we were doing, let's see which one I picked. For cos of 17 pi over 12, start with any family member you want. I started with 21 pi over 12, which is 7 pi over 4. I was like, ooh, I want to get close to 17. How about 7 pi over 4? That makes 21. Too much. So I had to subtract 4, which ends up subtracting pi over 3. And then you can use your alpha and beta formulas. And now you also have to consider what quadrants things are in, because sometimes they're positive, sometimes they're negative. Well, yes and no. The final fraction now has a root 6, root 2, but now the 6 is negative.
Like, right, but like for every solution that we came up with,
We're going to have always a root 2, a root 6, and a 4. And it's either positive or negative for the 2, positive or negative for the 6. So you have 4 choices, so you could take a 25% chance and just guess one. And then you would have a 25% chance of getting the half a mark for the right answer, and you'd lose the other 2.5 marks for not showing your work. So that's not bad. You should do that. By using my method, I've created a 100% chance I will fail. So this is cos of 17 pi over 12. Sometimes on the exam they have a part B. Part B says, can you find secant of 17 pi over 12?
isn't it just 4 over?
And then that would just be just the same thing, right? But you flip your fraction. One exam they just did secant of 17 pi over 12 directly. And you're supposed to find cos first of 17 pi over 12 and flip it. But those students that didn't think of that idea just left it blank, and then they got 0 out of 4. And so the exam committee felt bad for all the students that didn't do any work and got 0. So now it's, if it comes up as a part B. So you do part... Well, you can, but you have to do cos first, get your answer for cos, and then flip it for secant. That's how you would do it.
No identities for secant.
That's right, there's no identities for secant. Not that we've made, we could make them up if we wanted to. But and then here is an example of another exam question which was hard for students because they added a 4 in front. So if I go and I take away this 4, then it's exactly the same question as we just did. And then you would get a root 6 and a root 2 all over 4. What's going to happen when I add that 4 in front? You just take your final answer and multiply it by 4, which would cancel the 4 out on the bottom. But having that 4 in front, some students like, oh, I've never seen a 4 before in my life. I can't do this question. So sometimes you have to realize it's the same idea, just figure out the cos of 11 pi over 12 separately first, then take your final answer and multiply it by 4.
So, like, are we just going to space pi over 12 1? That's,
So now you can find any pi over 12 on your pi plate. So, and it's another thing you can, this always comes up on the non-calculator part because it's non-calculator. You're finding an exact value. Okay, question number 7 from your homework is the one that you can do for this, or you can try this one as well.